All right, folks, in this video, I'm going to summarize a simple principle called the law of superposition, which simply states that the layers on the bottom, the rock layers on the bottom are older than the rock layers deposited on the top. This slide here summarizes exactly what I need you to know, so if you'd like to pause it and review it, please do so. Here are some key vocabulary terms that I'm going to be using during this presentation, so if you'd like to pause it and review it and summarize, please do. So the main idea of the law of superposition is simply that the layers on the bottom are deposited long ago and the layers of sediment on top are younger. And what this allows us to do is determine the relative age or the approximate age of fossils and rock layers, which can be extremely useful in order to date how old a fossil or rock layer is. The relative age doesn't tell us the exact age of an object, such as a rock layer fossil, but it does tell us a lot about, its approximate age, which is really useful. There's two ways we can determine the relative age of something. One is the order of the rock layers, or the law of superposition, and another way is the use of index fossils, which I'll outline in another video. So in this video, I will be summarizing how we use the order of rock layers or the law of superposition to determine the relative age of rock layers and fossils. So this picture here I included because it is a real-world example of how the law of superposition applies. In this case, you might infer or assume that the clothes and the objects on the top were used more recently and put on top, and the stuff on the bottom was probably used or worn, much later. So, the clothes and the food that might be laying on top was probably, you can infer, used more recently than the items on the bottom. So it's just, the law of superposition does not, just apply to, rock layers and fossils. It's also used in forensic science and, some common sense examples. But when it comes to rock layers, the order of the rock layers is extremely useful in determining the age of fossils and rock layers and tells us a lot about Earth's history. So, um, the important part of this principle is really knowing that, this layer was deposited, first, and then younger layers are deposited on top of it. So the deeper we dig, the further back in time we do see. And this picture here is just a really simplified version of what we see in the fossil record according to the law of superpositions. In Earth's distant past, we see more marine or ocean sea-like creatures. And then, in the middle, we see more reptilian-like dominant creatures. And then in more recent history, we see, more mammal-dominant species of organisms in those rock layers. So the law of superposition states that each rock layer is older than the one above it. So the approximate or relative age of the rock or fossil in the rock or fossil is older if it's further down the rock layers. So that's a really kind of overcomplicated thing compared to just saying, the deeper you dig, the further back in time you see. So this cartoon summarizes it really well, I think. So the law of superposition states that each rock layer is older than the one above it. So this one would be considered the oldest, and this layer here would be considered the youngest. And this picture here is depicting how that process might occur. This right here, step number one would be, in Earth's distant past, and then sediments were deposited and this organism was fossilized. And then there was a time where reptilian creatures were more dominant. And then sediments were deposited on top of that fossil. And then in more recent time, we see more mammal-like organisms. So here's a more realistic picture of how the law of superposition could be useful. Here's a picture of the Grand Canyon. You can see that the layers down here were deposited first, and then layers were deposited on top of it over time. And here, they actually included some geologic, time periods here that were part of the Paleozoic era. So this would be hundreds of millions of years of deposition in various layers here. So what's interesting is that when we find fossils in the lower layer, we see, different environments and different organisms and different adaptations, and then organisms in more recent layers, have similarities and differences. But what the law of superposition does is it tells us, the approximate age of these layers here, in comparison to, layers that would be older down here. So according to the law of superposition, layer A would be the youngest and layer D would be, older. This picture here shows some people that are visiting the Grand Canyon. I wish it was me. Unfortunately, I haven't had an opportunity to go there, but I'd love to. But I wanted to show you, a more realistic version of the law of superposition. These layers here were deposited more recently, and the layers deep down here were deposited, millions, hundreds of millions of years before. And it's almost like a storybook of Earth's history. The fossils that we uncover in these different layers tell us a lot about Earth's past. So at this point, I would hope that you would be able to tell me that layer 1 would be, the youngest, and, layer 4 would be considered older according to the law of superposition. These layers were deposited first, and then sediments and sedimentary layers were deposited on top of it. So at this point, I would like to get you familiar with, some diagrams like this. Diagram A is a, real simple, example of the law of superposition. You got layer here on top would be considered the youngest. It was deposited more recently. And then layer G down here would be considered the oldest because it was deposited, first. And all these layers are on top of it. Diagram B is demonstrating that natural forces have eroded and weathered some of these layers away. This would be similar to the Grand Canyon, and but the law of superposition is still in effect. You have layer A here is on top, and layer G here on the bottom. So that would make layer G older according to the law of superposition. Diagram C here is trying to represent a little bit more realistic um, in nature, because in reality it's not always common that layers are in perfect horizontal layers like this. There are geologic processes that would cause layers to be pushed and moved, whether it's tectonic forces or other things that would cause layers to shift and move. But scientists are still clever, and they understand those processes and can still use the law of superposition to relatively date rock layers. So I still know that rock layer A, even though it's moved, is younger, and rock D here is the oldest, even though it is also moved. Then layer D here has an important element that I want to get you familiar with, is something called an intrusion. So sometimes magma will actually, ooze up into sedimentary rock layers. And I know this is younger simply because it's on top of these other rock layers. Even this one right here, you see that a little bit there, tells me that this intrusion is even younger than this layer here because it's on top. And as you go down, the rock layers get older and older and older. So I want you to get familiar with these kind of diagrams. This image here is very similar, but it has another element that I want to get you familiar with. Let's just start simply here. We got this rock layer here is the oldest because it's on the bottom. Then rock layer B is on top, and then rock layers on top of B. But what's interesting is you have this intrusion D, which is on top of C, B. And this intrusion letter D is also on top of layer A, so that makes D younger. What's also interesting is you have this, fault line here that has occurred after this intrusion even occurred. So, rock layer D would be the youngest rock layer. However, this earthquake or this fault and this slip occurred after this intrusion was created. And I know that simply because layer D is on top of everything, but the fault line cut or cracked this intrusion. So again, this is all based on the law of superposition. So what the law of superposition does is it allows us to relatively date or determine the approximate age of rock layers and fossils, which is extremely useful. However, this can only be done if rock layers were preserved in their original sequence. Even though that's not completely true, scientists are pretty clever and they can, you know, understand those forces and still make some, great inferences about the relative age of rock layers and fossils. The law of superposition is generally for undisturbed layers. So, in conclusion, we can determine the approximate age or the relative age of rock and rock layers and fossils in those rock layers using the law of superposition. The law of superposition states that horizontal layers in sedimentary rock, each layer is older than the layer above it and younger than the layer below it. So I know this layer is the oldest, and then these layers were deposited on top of it and are more recent and younger. So the deeper we dig, the further back in time we do see. I hope this lesson was helpful. Thank you.